All right, so you're learning about this fundamental theorem of calculus, and hopefully you have already reviewed that what we want is a function up here, which is what we have, but we want this to be a constant. So we end up just actually rewriting this integral. So in this case, I'm just going to leave the dx out front, but I'm going to rewrite this interval as x to the third to 1 ln of t dt plus 1 e to the 7x, because you know you can do that, right, with your integral properties. And now from here, oops, close my bracket. Again, I want the top bound to be the function. Well, I can reverse these with the negative. And now 1x cubed ln of t dt plus, same thing here, 1 e to the 7x ln t dt. And I'm pretty much home free now. So this is where we're going to use that whole chain rule thing. So this is going to equal the negative out front, ln, plugging in my upper bound, and then times the derivative of that upper bound, and then plus ln the next one, because all I'm doing is plugging in my function here of the upper bound times the derivative of the upper bound function, and that gives me negative ln of x cubed times 3x squared plus ln of e, remember those cancel and then the power comes down, would be 7x, and then this last piece, the derivative of e to the 7x, would be 7e to the 7x, and we can just make a final answer, kind of rearrange things. Ln x cubed plus 7 times 7, 49x e to the 7x. So the procedure for these are pretty much the same, okay, where you're manipulating your integrals to get the function up top and a constant in the lower bound, and then you go through the steps of plugging in your value of your function times the derivative of your function. Next one, plugging in the value of your function times the derivative of your function. And that's it for the FTC.